Unseen magmas have the potential to magnetize the swirls on the moon. Greetings, everyone. Today's video focuses on an intriguing topic. New research and data from spacecraft indicate that lunar swirls on the moon possess a magnetic property that causes them to repel solar wind particles and maintain their light color while surrounding rocks darken. The source of this magnetization may be attributed to underground lava formations that cooled in the presence of a magnetic field, resulting in magnetic anomalies. Experiments conducted with ilmenite, a mineral abundant on the moon, have demonstrated its ability to become magnetized under lunar conditions. Understanding these enigmatic swirls is of utmost importance when it comes to interpreting data collected from the lunar surface and upcoming missions, such as NASA's Lunar Vertex mission scheduled for 2025. So without any further delay, let us dive into our discussion. The enigmatic phenomenon known as lunar swirls has long stumped scientists, but recent advancements in modeling and the analysis of data collected by spacecraft have brought us closer to unraveling this perplexing riddle. Through careful examination, it has been discovered that the rocks within these swirls possess a magnetic quality, enabling them to divert the relentless onslaught of solar wind particles that incessantly pummel the moon. Instead of being directly impacted, the nearby rocks valiantly absorb the brunt of these particles. As a result, these neighboring rocks undergo chemical reactions that cause them to darken over time, while the swirls themselves retain their strikingly light hue. The process by which the rocks within lunar swirls became magnetized remains a mystery. Presently, the moon lacks a magnetic field, and no lunar swirl has been explored by astronauts or rovers to unravel this enigma. There is a possibility that these magnetic anomalies are a result of impacts, stated Michael J. Krasinski, an associate professor of Earth, Environmental and Planetary Sciences in Arts and Sciences at Washington University in St. Louis. He highlights the consistent delivery of iron-rich substances to various regions of the moon's surface by meteorites. However, there are certain patterns that we are unable to explain in terms of their shape and size solely through impacts. According to Krasinski, the swirls are more likely to have been magnetized by another local source. Krasinski, the researcher who devised experiments to investigate this hypothesis, suggests an alternative theory. According to him, there could be underground lava formations that cool gradually within a magnetic field, thereby generating the magnetic anomaly. The findings of his experiments have been documented in the Journal of Geophysical Research, Planets. In their study, Krasinski and Yuanyuan Liang, the lead author who recently obtained her PhD in Earth, Environmental and Planetary Sciences in Arts and Sciences, conducted experiments to investigate the potential magnetizing effect of various combinations of atmospheric chemistry and magmatic cooling rates on ilmenite, a mineral. According to Krasinski, the reason why Earth rocks are so easily magnetized is due to the presence of small fragments of magnetite, a magnetic mineral. However, this phenomenon does not apply to the moon, as it lacks this highly magnetic mineral. Therefore, previous studies conducted on Earth cannot be directly applied to lunar research. Krasinski and his team made the discovery that ilmenite, a plentiful resource on the moon, has the ability to react and generate iron metal particles that can be magnetized given the appropriate circumstances. According to Liang, the magnetic fields appeared to be more robust when dealing with the smaller grains. This is due to the fact that the smaller grains have a greater surface area to volume ratio in comparison to their larger counterparts. The increased surface area allows for a smoother reduction reaction process to take place in the smaller grains. According to Krasinski, a faculty fellow at the McDonnell Center for the Space Sciences, our analog experiments demonstrated the ability to produce the necessary magnetizable material under lunar conditions. Therefore, it is reasonable to propose that these patterns are a result of subsurface magma. The identification of the source of lunar swirls is crucial for comprehending the various mechanisms that have influenced the lunar landscape, including the magnetic field history of the moon, as well as the broader impact of planetary and lunar surfaces on the surrounding space environment. The findings from this research will play a crucial role in analyzing data obtained from upcoming lunar missions, particularly those focused on investigating magnetic irregularities on the Moon's surface. In line with this objective, NASA has plans to dispatch a rover to the Rhina Gamma region, a lunar swirl area, in 2025 as part of the Lunar Vertex mission. According to Kroczynski, in order to generate magnetic anomalies using the techniques outlined, it is crucial for the subterranean magma to possess a substantial amount of titanium. Although previous evidence from lunar meteorites and Apollo lunar samples suggests the occurrence of iron metal formation through this process, it is important to note that these samples originated from surface lava flows. Our research, on the other hand, demonstrates that the cooling process that takes place underground greatly amplifies these reactions that lead to the creation of metal. At present, his experimental methodology stands as the most effective means of examining predictions regarding the potential role of concealed lava in influencing the enigmatic magnetic phenomena observed in the lunar swirls. The current limitations prevent us from delving deeper to observe the occurrence of this reaction, as Kroczynski pointed out. Although it would be ideal to have that capability, it is unfortunately not feasible at this time. As a result, we are confined to examining only the surface. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.